Hello class, we're going to pick up where we left off in the notes about ocean and its currents. Today we're talking about one specific type of ocean current, which is the surface currents. So definition of surface current, these are small, which really means narrow, or large, meaning wider, streams of circulating or just moving water near the ocean's surface. So when we're thinking about from the top of the ocean surface down to about 100 meters, which is equivalent approximately to 300 feet. These surface currents are caused mainly by global winds. So that's the main cause of them. And keep in mind though, the main cause of the global winds is that sun's energy. So that's kind of what powers them, is the sun's energy collected by Earth's surface, transformed into heat energy. That heat energy is transferred to the air through conduction. And then we've got these convection currents in the air creating both local and global winds. And these winds that blow over the ocean, these massive global winds, affect the way that these streams of moving water flow. So I'm going to click on this diagram real quick before we get into how does Coriolis effect play a role in the ocean currents. And I want you to really try to understand how these global winds affect the surface current movement. So here, when we look at the diagram, we're just looking at surface currents. But as soon as I move my cursor over, I can see the global winds over top of the ocean. And just to recap, we've got these winds blowing kind of from the northeasterly direction to the southwest direction, and these are called the polar easterlies. So they're bringing that frigid cold air down. And then we've got the middle section of the northern hemisphere that is really experiencing prevailing westerly winds, and these come from the west. And lastly, closest to the equator in the northern hemisphere, we have what are called the trade winds, and the trade winds blow from the east towards the west. So keeping this in mind, if we focus just on the polar easterlies, we only have really one section to look at here, and we can see that that ocean underneath the polar easterly arrow right there is being pushed in the same direction as the polar easterlies. And when you focus closer up here, all of these by the prevailing westerlies or underneath the prevailing westerlies are also moving in a very similar direction as the westerlies. And last but not least, we've got these winds, trade winds near the equator. So anytime that the water is moving down towards the equator, it's going to be shifted from the northeast to the southwest. So the global winds, as you can see, have a major effect on the movement of these currents. All right, I'm going to click out of this and go back to our presentation. One thing that you do need to just kind of consider when you're thinking about how the winds affect the water is that when you have two things rubbing against each other, air particles against the water particles, that is friction. And this friction is going to increase the amount of thermal energy in that top layer of water. So that is kind of how that energy from the sun to earth to the air and then back to the water gets progressed through a cycle. And next we're going to talk about the two ways that the ocean currents are affected by the Coriolis effect, and it has to do with the global winds. The global winds curve the way they do due to the Coriolis effect. So when these surface currents all interact in these major oceans, there are loops or gyres that form, which we're going to talk more in depth about in a little bit. But these loops are going to go counterclockwise in the southern hemisphere. Sorry, I did these backwards. So water in the southern hemisphere is going to go counterclockwise, and the surface currents in the northern hemisphere all kind of circle clockwise. And we're going to go back to this one more time just so you can see and make sure you get that we have clockwise rotation in the northern hemisphere. There's another example, clockwise. But then if you look in the southern hemisphere, it is counterclockwise. So those are the two things that you need to know about the Coriolis effect, is that it affects the gyre rotation. And I do have a diagram on your notes that I would like for us to look at. And so what I would like you to do is just place an arrow showing what way the Earth rotates. And again, remember that it rotates counterclockwise. So I like to kind of get it going around like this. So a lot of times I would draw an arrow starting over here and just kind of going around the center of the Earth, showing that it's spinning in this direction. Once you've got that arrow drawn, and you might want to label it counterclockwise spin of Earth, just so you remember what that arrow is for, we are going to label two other things on this diagram. And it's just, we want to really focus in on the fact that when air and water move towards the equator, they don't move in the straight path. Because the Earth is spinning in the direction that you just labeled, what happens is when the air blows over the land, it's going to affect the land that's over here. And so we get this rotation. Okay, same with water. When the water is moving and the Earth is moving underneath it, you get this rotation in this clockwise direction due to the Coriolis effect, which is really just due to the Earth spinning. Okay, water moving from the South Pole towards the equator, and air, as we learned before, is going to get shifted this way, because again, remember that, look at the arrow that you just drew, the Earth is spinning in this direction. Therefore, something that starts here is going to end up more on this area of the planet because of the way everything is moving underneath that air and water. Okay, so again, we get clockwise movement in the northern hemisphere, we get counterclockwise movement in the southern hemisphere due to the Coriolis effect. So this affects our gyres, the ocean gyres. All right, we're moving on. Gulf Stream is an example, it's a major example of a surface current. It's one of the strongest surface currents. It has a major effect on global weather, especially in places near the Atlantic Ocean, which covers a lot of area of land. It is also one of the surface currents that is in the North Atlantic Gyre. And again, we're going to talk more about this. But if you can picture the Atlantic Ocean between North America and Europe, and you picture just the northern part, which is above the equator, you can kind of imagine that the Gulf Stream, which is pictured right here by this warm water flowing up the east coast, coming from the equator by Florida and traveling up into the northern part of the Atlantic, and then it hits land over here and it circles around. So we've got this North Atlantic Gyre right here. Big portion of this is the Gulf Stream, which runs basically from the equator, which is about here, all the way up the coast and across to Europe. And then there's this other colder current that runs back towards the equator on that side of the gyre. And so we get this rotating movement of water. Okay. So basically we've said everything on the notes. I would like you to use a colored pencil, and there's a box up on the front, but we've also got the red and the blue already in the bins. But you can just use a colored pencil to mark important elements on the map to describe the Gulf Stream. And I think that it pretty much describes that it's carrying warm water. So maybe draw in the equator in the map that you have. Yours is black and white. You might want to draw a line across showing the equator. You might also want to label North America so you know kind of more what you're looking at. This blob in the corner of our map is North America. And then you can draw an arrow that starts at the equator right around the tip of South America, the northern tip of South America, and it comes around by the Caribbean islands near Florida, and it kind of cycles around and goes up to Europe, okay? And that is the Gulf Stream. So we want to have an arrow, we want to have the equator, we want to have warm water shown on that arrow traveling upwards towards Europe. And we also want to have some continents labeled just so that we know where we are globally on the map. Okay. All right. So as far as the notes, it says, what do surface currents in the same part of the ocean form? And those form a gyre. So we're going to talk a little bit more about those. We just finished talking about the Gulf Stream, and it again is part of that North Atlantic gyre. But there are 5 main gyres, and then there's other little ones around too. However, in every major ocean, there's a gyre. And the eastern side of every gyre is cold because the water is coming from the pole area. And on the western side of the loop, the water is warm. And the reason why is that it's flowing from the equator. I like to remember that W, western, W, warm. So I just remember they both start with W, and that's how I remember. But if you think logically about that Gulf Stream, that's a great example. So the Gulf Stream is coming from the equator up all the way around the east coast of North America and then across to Europe. Well, that would be the western side of the Atlantic Ocean, not the western side of the United States, but we're focused on the ocean western side. And so with that, we have warm water coming up from the equator on the western side of that loop. There's another surface current that comes down from Europe and back down towards Africa and to the equator. That's carrying the cold water. And so that is the eastern side of the North Atlantic Ocean. And so it is carrying cold water on the east side. Every loop is like that. You can feel free to look that up online, Google it, or you can go back to that website I just pulled up and check it out. Okay? So if you think about North America, if you've ever gone to the Pacific Ocean on North America, and if you think about it, if we go to the Pacific Ocean, which I'm going to show you over here, if we go in North America and the Pacific Ocean, we're actually on the eastern side of this ocean. Okay? So California, Oregon, Washington State, those areas of our country border the eastern part of the Pacific Ocean. Now, what you're noticing here is the water that's flowing is coming from higher up areas in the northern hemisphere, closer to the poles, so they're going to be carrying cold water. Those of you that have ever swim in the Pacific Ocean near California or any of those places, you've experienced colder water. If you have gone at the same time of year to the eastern side of the United States, which would actually be the western part of the Atlantic Ocean, you are experiencing warm water. And it's all about the way that the surface currents flow, and meaning where they're coming from. So hopefully this all makes sense and you have your notes filled in as far as the first page. Now you'll notice that there's a second page that you glued in today. We are going to do a demo tomorrow, and you will be filling this in at that time. Thanks. Have a great day, guys.